Okay, in this video I'd like to show you how you can do really the same kind of stoichiometry we've been doing in previous videos, but apply it to the heat changes. And again, as I've mentioned before in previous videos, most chemical reactions involve some sort of a heat change or enthalpy change. In this case, the standard enthalpy change for this reaction is negative 1366.7 kilojoules. Now, a couple of things as far as understanding that. One, the negative means this is an exothermic reaction, because remember, delta H is the enthalpy of your products minus your reactants. So these have less energy than this, which is why I have a negative enthalpy change here. The other thing you need to recognize is that this is per everything you see here. So this is ethanol, and if I burn 1 mole of ethanol, it will react with 3 moles of oxygen, it'll produce 2 moles of carbon dioxide, 3 moles of water, and this much energy. If I were to cut the amount of ethanol in half, then I would get half of this amount of energy. If I were to double this, of course, I would get twice that amount of energy. Also, with these problems, you can also do limiting reactants. You could be given the amount of this and the amount of this, and again, same as before, you would simply compare them, find out which one is your limiter, and then use that one to predict the amount of heat that would come out of the reaction. So really, it's no different than any other stoichiometry we've done all along. It's just we're going to be looking at the heat, and we're going to look at the heat per moles that are given in the equation. So let me show you how this might work. So in this problem, this reaction, I'm told, gives off 951 kilojoules of heat, and again, by giving off we mean negative. So the energy released here is negative 951 kilojoules of energy. Well, now what I'm going to do when you do dimensional analysis is I'm going to put the kilojoules here, and what is that per? Well, notice this is per, as I go through this, 3 moles of water. So if you notice in this equation, if I was trying to find, now why do I focus on water? Notice in the equation, they're asking about the water. So what I'm going to say is that they want to know how many molecules of water are being produced. So what I would say is that this negative 1366.7 kilojoules is per 3 moles of water. Now, the reason I'm doing the water is because that's what they want. They want to know the molecules of water. If they were asking how much ethanol is required maybe to give 951 kilojoules, I would do this per moles of methanol or oxygen. But since we're dealing with water, this is the way I'm going to set the equation up. And again, please note, it's 3 moles of water will release this amount of energy. So every 3 moles of water, I'll get this amount of energy. Now, if I were to stop here at this point, I now know the moles of water. So if I have this much energy coming out, I know this much energy comes out for every 3 moles. By doing this math, the kilojoules will cancel, and I'll have moles of water. They don't want moles of water, they want molecules of water. So now I'm going to add my conversion. I'm going to go from moles of water to molecules of water. And again, your conversion, 1 mole, the number of things in a mole, molecules or atoms or whatever, is 6.02 times 10 to the 23rd. So at this point, I just do my math, and I did this before, I believe, and if I got the correct answer, I have 1.26 times 10 to the 24th molecules of H2O. So again, that's all you're really doing when you're dealing with the heat reactions. I could also have given you maybe, let's say you have 5 grams of this, how much heat will come out. And again, I would simply start with the 5 grams, and let me just kind of show you how that will work. If I start with 5 grams of C2H5OH, I'm sorry, let me clean that up a little bit, OH, and again, I would just simply go from grams of ethanol to moles of ethanol, and again, this is 1 here, and then I get the molar mass of ethanol, and I'm not sure what that is at this point. We can figure that out later. And then I would go from moles of ethanol, and again, that is 1 mole, and I could do kilojoules of energy. And then I'd put my 1366.7. So again, what I would do is basically take the grams, turn it into moles by dividing by the molar mass, and then multiply that by the heat per that number of moles. So you can do this a lot of different ways. Here I was given the energy, and I figured the amount of water, molecules in this case. I could give you the grams or molecules or liters of a gas of any one of these things, and I could say how much heat would come out. But again, notice that whatever I'm either going to, water, or starting with, I use my relationship in the equation, the number of moles of that thing with the heat given for that reaction. All right, I hope this helps a little bit.